Good morning everyone. My name is Rupa Rani and I'm working in Akgec in CSC department. Today we'll study the introduction of DA, algorithm and characteristics. Now, first of all we will see the syllabus of DA. In the syllabus of DA we have these 5 units and we will start from the unit 1. We will discuss algorithms and analyzing of algorithm in today's lecture. Now, start with the definition of DA. Means what is the meaning of DA? DA is design and analysis of algorithm. This is a combination of 3 words: design, analysis and algorithm. I'm going to explain this with a diagram. Just see. Suppose we have a problem. To solve this problem, we need to design an algorithm. Right? After this, you will create a program. But to create this program, you need some data structure. Right? If you know algo and data structure, both these terms, both these things, then you can create a program. Now, what do you mean by this data structure? Data structure you have already studied in the previous year semester. It's a way of organizing and storing the data in an efficient manner. Now, with the help of this data structure and algorithm, we are creating a program. But how to design this algorithm? Question is how to design algorithm. Data structure you already know, you have studied in the previous semester, already you have done the programs of data structure. Now the question is how you will design the algorithm. To design the algorithm, we will study unit 3, 4 and 5 in the syllabus of DA. In the syllabus of DA, unit 3, 4, 5, you will learn how to design the algorithm. After designing the algorithm, second term is how to validate. Means the algorithm you have designed, is this meaningful or not? Is this feasible or not? Is this possible or workable or not? That's why you have to validate it. And the third question is, after designing the algorithm, you have to check the time and the space the algorithm is taking to run. Right? For that, you have to do the analysis. And analysis can be done in 2 parts, by finding the time complexity and space complexity. Analysis you can done in 2 parts. You have to find the time complexity and you have to find the space complexity. Time complexity means how much time an algorithm is taking to run the program and how much space it is taking to run the program, same program. Through the analysis, you can check whether it is okay, algorithm is okay or not. If it is taking sufficient time or less time and less space, then this is okay. Now, first one and the third one you will study in your syllabus. In unit 1, you have algorithm and analysis of algorithm. And third is complexity. And rest are the shorting algo, which are the same as you have studied in last semester in data structure, right? Mainly you will study in unit 1 algo and algorithm means what do you mean by the algorithm, definition of algorithm, and the analysis of algorithm means you will find the time complexity and space complexity, and then you will do the analysis, right? So these two terms, this analysis, this is a combination of analysis, designing and algorithm. So this algorithm and this analysis part you will study in unit 1. Right? And this designing part you will study in unit 3, 4 and 5. And unit 2 contains some advanced data structure. I think now the introduction part or the syllabus is clearly understandable to you. I told you that is a combination of 3 terms: design, algorithm and analysis. You will study algorithm and analysis in unit 1, and designing you will study in how to design the algorithm. You can use various approach, like you have you can see here divide and conquer approach, greedy method, dynamic programming, backtracking, etc. These methods you will study in unit 3, 4 and 5. These are the designing method. And in analysis part, as I already told you, time complexity and space complexity. Now see the definition. DA is a fundamental aspect of computer science that involves creating efficient solution to computational problem. I told you the problems, right? And evaluating their performance with the help of analysis. DSA focuses on designing algorithms that effectively address specific challenges and analyzing their efficiency in terms of time and space complexity. This is the definition of DA. I think this topic is very much clear to you now. Now we will see the first topic, algorithm. What is an algorithm? Algorithm is a set of steps to complete a task. Now I am going to take an example. As you can see here, when you cook, you follow a recipe to prepare a dish. This is a live example. Second, when you play a game, you are devising a strategy to help you win. Means you have to follow some strategies to win the match. Now, in computer's language, you can say algorithm is a set of instructions followed to solve a particular problem or to perform a task that is described precisely enough that a computer can run it. Means it's a simply set of instructions to solve a problem or to perform a particular task. Now I am going to take a real life example. Suppose I say, prepare a cup of tea for me. Then what will you do? You have to add some water and milk to the kettle, first of all. Second, you have to boil it, add tea bags, add sugar and then serve it in a cup. You cannot do that first you will take the sugar and then serve it in a cup and the second point you add the water. This is not possible. You have to follow the strategy or algorithm or set of instructions. Then you can prepare a cup of tea. Right? This is the algorithm. Now, there are some characteristics of any algorithm. Any algorithm must satisfy the following characteristics. First of all, input means input may be 0 or more. As you already know, in the first year, you write a program, print hello world. In that program, is there an input? No, there was no input. You just you simply write down print hello world, means input is 0, but you are getting one output there, that is print hello world only, right? It means you can take 0 input or more input. If I take another example, suppose you are doing selection sort. In that case, you are taking the value of n equal to 5. Suppose you have written n equal to 5. It means you can write 5 numbers only. Means there is some input value and you will get a output, a sorting string, a sorting numbers, sorted numbers. Means there are some input. But in first one, hello world, as you are taking the output, there is no input. So this is the meaning of first term. There are 0 or more quantities or more inputs externally supplied. Output, you are taking 0 input or more input, but there is exactly one output. In the first case, you are taking the output hello world. In the second case, you are taking the output assorted numbers like 2, 3, 4, 5. Means there is exactly one output or one quantity, at least one quantity. This is output. Third is finiteness. I am taking an example of for loop. Suppose there is a number n and n equal to 5 in for loop. Means as you have the number more than n, then loop will be terminated. It means there is some finiteness. You have taken a number n equal to 5. After this number, this will be terminate. See here, if we trace out the instruction of an algorithm, then for all cases, the algorithm will terminate after a finite number like n equal to 5 of steps. Next is definiteness. Each instruction must be clear and unambiguous. Like I am taking an example, int a, and a equal to 5.0 by 2. Is it possible? This is a float value. It's not possible. There is some error. There will be some error when you run the program, right? There is some syntactical error. It means each instruction in an algorithm must be clear, must be unambiguous. This is a ambiguous statement, right? Now see the next one, effectiveness. Every instruction must be sufficiently basic and every statement in algorithm should perform some operations. It is not enough that each operation be definite, but it must also be feasible. Means the problem what we are going to solve and we are taking the solution, that solution must be feasible. Means that solution must be effective, right? Suppose solution is taking more and more time and more memory, then this is not feasible. This is not workable in the real life implementation. You cannot implement it. So it must be feasible. Next is the correctness. Algorithm must produce correct result. Means the algorithm what you are taking, that must produce correct result. Means I have given you a problem, selection sort, and you are finding the output through the quick sort. if I'm giving add two numbers, but here you are taking the output, subtract two numbers, means this is not exact result. There is some result, but this is not correct. Whatever the problem you have and whatever is the desired solution, that must be as output after running that algorithm or running that program, sorry. These are the characteristics of an algorithm. Now we can say that algorithm is a finite sequence of instruction, each of which has a clear meaning and can be performed with a finite amount of efforts in a finite length of time, no matter what the input value may be. As I told you, input value may be 0 or more. An algorithm terminates after executing a finite number of instruction, as I told you, n equal to 5. After that, the algorithm will be terminate, right? This is the meaning of algorithm. Now we will see what are the various steps required to construct an algorithm for solving the problem. First of all, in the first slide, I told you, suppose you have to solve a problem. To solve that problem, you need to design the algorithm. The first step is problem definition. You need to know what is the problem in real life. According to that problem, you have to design the algorithm. To design the algorithm, you need some data structure, and then you will write a program. For that, in third step, you will create a flow chart or pseudocode, and that you have to validate. I told you in the first slide, in third steps, how to validate. Now, validation or verification you have to do. After this, you have to analyze the algorithms, means you have to check the time complexity and space complexity. And in last, the implementation work, means you have to run the program on your system. You have to give some input and you will find some output. These are the steps required to solve, required to construct an algorithm. Thank you everyone. Next topic we will study in the next video.